Now, let us talk about the physical properties of physical change or different substances. When we talk about the physical properties, we observe that these are observed and measured without change in composition. As I told you, if I melt ice, we observe that ice in solid form changes into water in liquid form, but the formula would be same, H2O. In ice, the formula is H2O. In water, again the formula is H2O. So I can say that there is no change in the composition. There is no change in the substance that has been formed during this process. That means it is exactly the same substance. So very first thing is the physical changes or physical properties are observed and measured without changing in composition. That means there is no change in composition. So now on the basis of various examples, we can say that physical change is a change in which no new substance has been formed, no change in composition has been observed. But when we talk about chemical change, we observe that a new substance has been formed. Like if I talk about the burning of magnesium wire, new substance has been formed. If I say milk changes into curd, what is this? A new substance has been formed. Is the property of curd similar to that of milk? Is the taste of curd similar to that of milk? No. New substance has been formed. That is chemical change. And if I ask you, can I convert this curd back into milk? Is it possible for you? No. So, we can say that chemical change means a new substance has been formed which has different properties. So, if I ask you milk and curd, they have same properties? No, they have different taste. If I ask you the property of magnesium and the property of magnesium oxide, they are different. Clear? Magnesium is metal, magnesium oxide is basic nature substance oxide. When we talk about chemical change, we also say that it involves some changes during the process known as chemical reaction. Now let us see. These are iron rods. We call it as sariya in Hindi, used for construction, making roofs during RCC. Iron rods, iron articles. You can see some rust on the surface of this iron, and that damages the complete iron object. So what is this basically? When we see this iron rod, we see this iron object, we observe that some substance has been formed that damages this iron object completely. We call this as rusting of iron. And this is the substance rust that has been formed on the surface of this iron object or iron rods. We see that this rust damages the iron object completely after some time. So what is this rust? Or first of all, if I ask you, is it a chemical change or a physical change? Yes, absolutely right. It is a chemical change. Why it is chemical change? Because iron has changed into some new substance that we call as rust. And even some chemical reaction also takes place. Iron in presence of oxygen and water in the form of moisture changes into rust, which has the formula Fe2O3 with some moisture content in it. So when we talk about a new substance has been formed, definitely it is a chemical change. Another thing is, can this rust be converted back into iron object? No, it is irreversible process. So it is chemical change. So first thing is, it has different composition. Both iron and rust have different composition. Second, a new substance has been formed. And third, it has different composition. You can see the example as we have discussed just now, milk into curd. So this is again a chemical change. Milk can be changed into curd, but reverse is not possible. A new substance has been formed which has different composition from the previous one. Chemical change. Burning of wood. Once the wood is allowed to burn, what will happen? It changes into coal. It changes into ash. Can I convert this ash back into wood back again? It is not possible. So this is again a chemical change, and a new substance, that is ash or coal, has been formed along with the liberation of carbon dioxide, some moisture content and a good amount of heat in the form of energy has been released during this process. And this ash cannot be converted back into wood. So that is again irreversible process, and thus since a new composition of substance has been formed, so it is chemical change. So as we have discussed in various examples that these are chemical changes which involve some formation of new substance, like milk changes into curd and it cannot be reversed back, so it is a chemical change. Burning of this wood is a chemical change. So all these we have discussed. Now one more thing that we have discussed earlier, burning of magnesium wire. Now we'll discuss in detail how this burning of magnesium wire takes place. So when we take a burner and bring a magnesium wire to it, it starts burning like a white dazzling light. And this white dazzling light comes out when we take this magnesium wire and we bring it to the burner. We observe that this magnesium wire, which has been held with the help of a pair of tongs, one apparatus to hold this for safety reasons, and finally once the reaction takes place, a new substance has been formed, and you can see some white ash starts falling down in this china dish. That is nothing but the white powder, white ash, that is magnesium oxide. Let us see how this chemical reaction takes place. So what we have done, we take a strip of magnesium wire, we rub it with sandpaper so that we just clean the tip of this magnesium wire so that there will be no unwanted substance or material remain and it starts burning easily. Once we bring it to the flame or burner, we observe that it burns with a white dazzling light and finally it starts changing into this white ash. This is nothing but magnesium oxide. Now, how this reaction takes place? So we have taken magnesium wire, the symbol is magnesium Mg, and it reacts with oxygen. The oxygen is available to this magnesium wire from the atmosphere and we get magnesium oxide. So this is how the reaction takes place. This oxygen we get for this magnesium wire, for the burning of this magnesium wire, we'll get it from the atmosphere and ultimately we'll get this magnesium oxide. So whatever this ash has been formed, let us do an experiment with this ash and try to find out, is this ash a different substance from the magnesium or not? We'll take this ash and mix in water and we add some red litmus paper. The change observe is that the red litmus paper changes into blue. So this is how the change takes place. So red litmus paper that changes into blue, it means that this magnesium oxide is basic in nature. So what we have done is we have taken this magnesium oxide, add some water to it, it changes into this paste that magnesium hydroxide has been formed, which is basic in nature. And we know that a base can turn red litmus to blue, but blue litmus to red will not take place. So we observe that this magnesium hydroxide, which is basic in nature, it has a capacity to change red litmus to blue. It shows that this magnesium hydroxide is basic in nature. So what will happen? We have taken this ash, we dissolve it in water and we observe some new substance has been formed. And this new substance is nothing but magnesium hydroxide. So we have that ash which is nothing but magnesium oxide. We add water to it and finally we get magnesium hydroxide. So you can see another example of this chemical change. What we have done is, here we have taken copper sulfate solution, which is this blue in color, and we take iron sulfate solution. On mixing these two, after some time we observe that there is some copper deposit. Basically what will happen, if we take some iron nails and place it in blue color copper sulfate solution, we observe that there is some deposition of copper on the surface of iron nail. So what we have done, we have taken iron and we add this iron nail into copper sulfate solution. After some time we observe that this iron changes into iron sulfate, which is green in color, and there is some deposition of copper on this iron nail, and the change in the color of iron nail is from normal grayish metallic color to reddish brown color, that is of copper. So it shows that the reaction takes place and a new substance has been formed. And what is the reaction? The reaction is iron changes into iron sulfate and copper sulfate changes into copper. So we get iron sulfate, which is now green in color, and the copper sulfate, which was earlier blue in color, now get deposited in the form of copper on the surface of iron nail. So this is how the reaction takes place and a new substance has been formed. And you have easily visualized the change in color with the help of this reaction as we have discussed earlier. So this change in color very well explains that there is some new substance formed, and that's why we call it as a chemical change. Now let us talk about an activity. When we talk about this activity, we say that we have taken vinegar. What is vinegar? Vinegar is acid, acetic acid, and we add some baking soda to it. On adding vinegar to baking soda, we observe that some gas has been evolved, and this gas is nothing but carbon dioxide, the same gas that we exhale during respiration. So this carbon dioxide has been formed in this reaction. So in this test tube, you can see some bubbles comes out, and these bubbles have been collected in this delivery tube and is allowed to pass into another test tube which has lime water in it. The color of lime water is as that of water. It is colorless, it has no color. But as soon as this carbon dioxide which is produced in this test tube, it passes into this one, goes to this lime water, start reacting with it and convert it from colorless to milky color. Milky means somewhat white color. So this carbon dioxide starts reacting with lime water and changes its color. So the change in color is milky. Let us see how this reaction takes place. So when we talk about vinegar, we know that vinegar is acetic acid. We add baking soda to it, which is nothing but sodium hydrogen carbonate. On mixing these two, we observe that this carbon dioxide has been formed. Now this carbon dioxide is allowed to pass into another test tube which already has lime water in it. Now this carbon dioxide reacts with lime water and it changes into milkiness. Milkiness means white color. Now why do we get this milkiness from colorless to white color has been observed? This is because of the formation of this calcium carbonate in the test tube. So when lime water reacts with carbon dioxide, we observe that calcium carbonate has been formed, which is actually white in color, which is actually insoluble, thus shows its color along with water. So this is how a new substance has been formed, and thus this is again a chemical change. So these chemical changes are very, very important in our daily life also. So first thing is new substance has been formed, that is chemical change, and most of these are irreversible. That means that cannot be reversed back. So first thing is when we talk in our daily life, we observe that the digestion of food in our body is nothing but chemical change, as it involves the formation of a new substance. So digestion of food in our body is nothing but chemical change. Ripening of fruit is nothing but chemical change. Fermentation of grapes that result in the formation of beer and alcohol, that is also chemical change. So basically these are certain examples that we deal with it in our daily life. It is used in medicines. Some good medicines are there that is responsible to heal up, to cure us from disease. Then these chemical changes are also responsible for digestion. In addition to new products, the following may accompany a chemical change. Let us see what are the other changes during a chemical reaction. So when we talk about a chemical reaction, involves some change in heat, some evolution of gas, some light has been observed, some radiations has been emitted out. So basically overall when we talk, we observe that some heat or light or radiation comes or been absorbed during the reaction. So a new change has been observed, not only in terms that new substance has been formed, but along with that some change in energy has also been observed. Then maybe in some cases sound may be produced, like firecrackers. They produce light, colorful lights, different colors. Similarly, sound may also be produced in some cases. In some cases, change in smell may also be observed due to formation of a new substance which may have some good or bad smell, or due to evolution of some gases which again may have good or bad smell. Similarly, some change in color, as we have observed in the case of copper sulfate solution, in the case of rusting of iron, we observe a new color has been observed. A gas may be formed, so we observe some new gas may be formed, as we have discussed the case of vinegar and baking soda, and carbon dioxide has been released. So these are some changes that involves the formation of a new chemical substance, and we call it as chemical change. So here you can see certain examples, like the fruits we have seen, like rusting of iron we can see. So when we talk about rusting of iron, a good iron substance may change into unwanted, undesirable, that harms the surface of metal, and day by day its surface is deteriorating and it goes off. That means its life is reduced just because of formation of new substance on the surface of iron that we call as rust. So basically when we talk about rust, rust is nothing but a formation of new substance on the surface of iron. And it takes place when iron is exposed to oxygen of the atmosphere and moisture of the atmosphere. So this is how the rusting takes place. So if I ask you what is the reaction that takes place during rusting process, so I can say that the iron react with oxygen, and this oxygen is available to the iron metal from the air, along with some water vapors present in the moisture or in the atmosphere. And all these three combine together to form a new compound, that is rust. Though this rust is not useful, it harms the surface, it harms the substance iron, so it is not good. So when we talk about the rusting, rusting is possible only when this iron exposed to oxygen and it is exposed to water. So two important conditions are there for rusting. One is oxygen and other is water. In the absence of any one, the rusting will not occur. So if we cover the surface of iron by any means, rusting stops. So now the question is, how can we prevent rusting? Because rusting is not good. Rusting always reduces the life of iron. So we can prevent just by not allowing oxygen or water to come in contact with iron. So it's a very simple thing is when we cover the surface of iron by oiling, by painting, by greasing, so by applying some layer on the surface so that water or oxygen cannot directly attack to the surface of metal, that is a good way of preventing iron from rusting. Even we can apply a layer of zinc or layer of chromium on the surface of iron, that also helps iron from rusting. So this is how we can prevent rusting, by just applying a surface of any metal on iron. So when we apply or when we coat a layer of zinc on the surface of metal, we call this process as galvanization. So if I ask you, what is galvanization? I say that it is the process of depositing a layer of zinc on the surface of iron. So it is very much helpful when we are having the iron pipes which are used to carry water. They are always galvanized. So they are galvanized means they are coated with the surface of zinc, so that zinc doesn't allow oxygen or water to come and directly apply on the surface of iron, so that the rusting will not take place. So this galvanized iron is very good for prevention of rusting from iron. Similarly, when we talk about these sailboats or ships, these are again made up of iron object and they remain in water. That means the surface of these boats they get corroded very easily and in no time. So they need maintenance from time to time. Now, let us discuss again what are the essential conditions for rusting of iron. So we have discussed that two conditions are important. One is oxygen and other is water. So by any means, if we do not allow any of these two, we can prevent iron from rusting. Now there is one more way by which we can prevent iron from rusting, and that is convert it into alloy. And when iron is mixed with small amount of carbon and other metals like chromium, nickel and manganese, then this iron changes into an alloy, and that alloy is a stainless steel. So this stainless steel means it is stain free, it has no rust, and thus this iron, by changing into alloy, can be prevented from rusting. And that is one of the very good way and the cheaper way to prevent iron from rusting. The utensils of stainless steel we actually are using in our home also for eating, for other purpose.
To watch the complete video, download the Upbind educational app from Play Store and App Store.